Hello everyone, my name is Mini Sethi. I hope you all are staying healthy. Today we are going to talk about theory of production for UGC Net. And topics for today's video is, in short time period law we will talk about law of variable proportion with the help of proper table and diagram. And in long time period we will talk about law of return to scale, isoquant, types of isoquant, Isocost line and least cost combination with the help of proper table and diagram, and we will also talk about Cobb-Douglas production function. So let's start it. First of all, we are going to talk about short time period law, law of variable proportion. Before understanding this law, you must know about total product, marginal product and average product. So what is total product? Total product is total quantities of goods which are produced by a firm during specific time period. For example, total quantities of goods which are produced by a firm during specific time period is 250. So 250 will be called total product. So what is marginal product? Marginal product means change in total product when we apply one more unit of variable factor. Here we assume our variable factor is labor. So we can say that marginal product means change in total product when we apply one more unit of labor. For example, total product of 5 labor is equal to 30 kg. And when we apply one more unit of labor, or we can say that total product of 6 labor is equal to 35 kg. After applying one more unit of labor, change in total product is 35 minus 30 is equal to 5. This 5 will be called our marginal product, because marginal product is change in total product when we apply one more unit of labor. So what is average product? Average product is output per unit of labor, or we can say that average product is output per unit of variable factor. Per unit means output produced by only one labor. For example, if TP of 5 labor is equal to 30 kg, 30 kg divided by 5 is equal to 6 kg. This 6 kg will be called output per unit of labor, or we can say that this 6 kg will be called output which is produced by only one labor, and this will be called our average product. Now we are going to talk about table of law of variable proportion. So what is law of variable proportion? Law of variable proportion is short time period law. And in short time period, we don't have so much time to change all factors of production. That's why in short time period, we can only change our variable factor labor, but cannot change our fixed factor land. And this law basically states that when we are applying more and more unit of labor on our fixed factor land, then how it will affect our production. So in this table, in first column, we have our variable factor labor, which we can change. Second column we have our TP. TP means total product, as we earlier discussed. Next column we have average product, AP. Average product means product of only one labor. If product of 2 labor is 60, 60 divided by 2 is equal to 30. 30 is our average product, which is product of only one labor. Similar, you can calculate for other unit. And in this column we have marginal product. And marginal product means the change in total product when we apply one more unit of labor. Here you can see one labor is producing 20 output. When we applying one more unit of labor means product of 2 labor is 60. After applying one more unit of labor, change in total product is 60 minus 20 is equal to 40. This 40 is our marginal product. Similar, product of 2 labor is 60 and product of 3 labor is 120. Change in total product after applying one more unit of labor is 120 minus 60 is 60. This 60 will be called our marginal product. Similar, you can calculate for other units. Now we are going to talk about stages of production. First stage is increasing return to variable factor. Our variable factor is labor. Increasing return to variable factor means marginal product of labor is very high in first stage. Here you can see marginal product is more than average product. Marginal product is 40, but average product is 30. Marginal product is 60 and average product is 40. At the end of first stage, marginal product is become equal to average product. So we can say that increasing return to variable factor means marginal product of labor is very high. Means when you are applying additional unit of labor, you are receiving more output. But why marginal product of labor is very high during this stage? Because complete utilization of our fixed factor. For example, this land is our fixed factor, and for working in this land we need 5 employees. Initially we only have 1 employee. That means our land is underutilizing. But when we are applying second, third, fourth labor to working in this land, that means our land is completely utilizing and giving us more output. So this is main reason we are getting increasing return to variable factor in first stage. In second stage is decreasing return to variable factor. Now marginal product of labor start reducing. Here you can see marginal product is less than average product. Marginal product is 20 but our average product is 30. At the end of second stage our marginal product becomes 0. But why marginal product start decreasing? Means now overutilization of land. In this land only need 5 employees to work, but we are applying 6, 7, 8, 9, 10. That's why we are not receiving more output. So overutilization of land is main cause of decreasing return to variable factor. Third stage is negative return to variable factor. Now a marginal product of labor become negative. Here you can see marginal product of labor is minus 20 because too much overutilization of our fixed factor land. Our land don't have capacity, but we are applying more and more unit of labor. That's why marginal product of labor become negative. Now we are going to talk about diagram of low variable proportion. If you convert previous table into a diagram, you will get this. In this diagram on x-axis we have labor, and y-axis this side we have total product TP. This side we have MP and AP. MP means marginal product and AP means average product. This curve represent our total product TP. And this curve represent our MP means marginal product, and this curve represent AP. AP means average product. Here we have 3 stages, stage 1, stage 2 and stage 3. Stage 1 we are getting increasing return to variable factor. Stage 2 we are getting diminishing return to variable factor. Stage 3 we are getting negative return to variable factor. You can see at first stage our TP increasing, MP and AP also increasing. But at first stage our marginal product is more as compared to average product. You can see our marginal product is more as compared to average product. This diagram represent our marginal product and this diagram represent our average product. You can see marginal product is more than our average product in first stage. At the end of first stage marginal product become equal to average product. Now we are going to talk about second stage, which is called diminishing return to variable factor. That means now marginal product of labor will reduce. Here you can see marginal product of labor is less than from average product. This is average product curve, this is marginal product curve. In second stage marginal product is less than average product. At third stage you can see our marginal product become negative. This is our third stage. Here you can see our marginal product become negative because too much overutilization of our fixed factor land. Now we are going to talk about law of return to scale. Law of return to scale is a long time period law. And in long time period we can change all factors of production. Means in long time period all factors are variable, no factor is fixed. Or we can say that in long time period we can change scale of production by changing all factors of production. And when we change scale of production by changing all factors of production, 3 possibilities can arise. One is increasing return to scale, second is constant return to scale, third is diminishing return to scale. One by one we discuss about each. First of all, we are going to talk about increasing return to scale. Increasing return to scale means a percentage increase in output is more as compared to percentage increase in input. Means we are receiving more output as compared to input we are giving. Here you can see first column we have labor and second column we have capital. Labor and capital are our inputs. Third column we have total output. Fourth column we have percentage change in input. Last column we have percentage change in output. One labor and one capital are giving 100 units of output. But as we increase our labor and capital from 1 to 2, our output increase from 100 to 120. Here you can see percentage increase in input is 100%. We increase our input from 1 to 2. But percentage increase in output is 120%. Our output increase from 100 to 120. So here you can see percentage increase in output more as compared to percentage increase in input. So it will be called our increasing return to scale. Same thing you can see in this diagram. On x-axis we have labor and y-axis we have capital. One capital and one labor are giving 100 units of output. But as we increase our labor and capital from 1 to 2, our output increase from 100 to 220 units. So here you can see percentage increase in output more as compared to percentage increase in input. So it will be called increasing return to scale. Now we will see constant and diminishing return to scale. Constant return to scale means percentage increase in output same as compared to percentage increase in input. Here you can see when we increase our labor and capital from 1 to 2, our output increase from 100 to 200. So here you can see percentage increase in input is 100% and percentage increase in output is also 100%. So percentage increase in output is same as compared to percentage increase in input. Same thing you can see in this diagram. One labor and one capital are giving 100 units of output. When we increase our labor and capital from 1 to 2, our output increase from 100 to 200 units. So here you can see percentage increase in output is same as compared to percentage increase in input. Now we are going to talk about diminishing return to scale. Diminishing return to scale means percentage increase in output is less as compared to percentage increase in input. Here you can see when we increase our labor and capital, which are our input, from 1 to 2, our output increase from 100 to 180 units. So here you can see percentage increase in inputs are 100%. We increase our labor and capital from 1 to 2. But percentage increase in output is 80%. Our output only increase 100 to 180 units. So here you can see percentage increase in output is less as compared to percentage increase in input. So it will be called diminishing return to scale. Same thing you can see in this diagram. One labor, one capital are giving 100 units of output. When we increase our labor and capital from 1 to 2, our output increase from 100 unit to 180 units. So we can say that percentage increase in output less as compared to percentage increase in input. So it will be called diminishing return to scale. In diminishing return to scale, we receive less output as compared to input we are giving. Now we will talk about isoquant. Isoquant shows different combination of labor and capital which give us same amount of output. Isoquant shows different combination of labor and capital which give us same amount of output. Here you can see first column we have combination, second column we have labor, third column we have capital, last column we have output. At A combination, we are using 1 labor and 12 capital and getting output equal to 100. At B combination, we are using 2 labor and 8 capital and getting output equal to 100. Similar, you can see other combination C, D and E, but main thing is that whatever combination of labor and capital you will use, you will receive same amount of output equal to 100. So we can say that isoquant shows different combination of labor and capital which give us same amount of output. When we convert this table into diagram, we will get this. In this diagram on x-axis we have labor and y-axis we have capital. Here you can see different combination as we earlier discussed, A, B, C, D and E. Whatever combination of labor and capital you will use, you will receive equal 100 amount of output. When we join all this combination, we will get one curve. This IQ curve will be called our isoquant curve. Now we are going to talk about types of isoquant. First type is linear isoquant. Linear isoquant shows perfect substitutability between factors of production. Means according to this isoquant, factors are completely substitute with each other. Means we can completely use labor in place of capital or capital in place of labor. Here you can see on x-axis we have labor and y-axis we have capital. Either you can produce by using OL amount of labor or you can produce by using OK amount of capital. Means you can completely replace this factor with each other. This isoquant also called straight line isoquant. Here you can, there is one straight line. Second type is right angle isoquant. According to this isoquant, factors are complementary with zero substitution. According to this isoquant, factors are complementary with zero substitution. Means for producing particular amount of output, we need both factors. We cannot replace one factor with each other. Means we cannot replace capital with labor. For producing particular amount of output, we need both factors of production. In this diagram, you can see for producing particular amount of output, we need both. We need OK amount of capital and OL amount of labor. We cannot substitute factor for each others. Next is a kinked isoquant. According to kinked isoquant, factors have limited substitutability. Means at certain limit we can substitute the factor of production but not beyond this limit. In this diagram you can see we have 4 methods of production, P1, P2, P3 and P4. Here you can see one kinked curve A, F, and we can substitute factor within the limit of this kinked curve. Or we can say that we can substitute factor of production within these points A, B, C, D, not beyond this point. because according to this isoquant, factors of production have limited substitutability. At certain limit we can substitute factor of production for each other, not beyond this limit. Next is smooth convex isoquant. This isoquant shows continuous substitutability of factor of production over a certain range. Means over a certain range we can continue substitute our factor of production. In this diagram, this A, B, C, D, E, F combination shows continuous substitutability between factor of production over this range. When we join all this point, we will get our smooth convex isoquant. Main difference between kinked and smooth isoquant is that kinked isoquant don't show continuous substitutability, but smooth isoquant shows continuous substitutability between factor of production over a certain range. Now we are going to talk about isocost line. Isocost line shows various combination of labor and capital which firm can purchase with given price of capital and labor and with given amount of money. Means whatever combination of labor and capital firm can purchase with given price of capital and labor and with given amount of money is represented by isocost line. Here you can see first column we have combination, second column we have unit of capital, third column we have unit of labor, and last column we have total expenditure, or we can say the given amount of money that firm have. And price of one capital is 30 rupees and price of one labor is 10 rupees. Here you can see different combination of capital and labor. But whatever combination of capital and labor firm will purchase, its cost will equal to 120 rupees. Here you can see price of one capital is 30 rupees. 4 multiplied with 30 is equal to 120. You can see cost of first combination is 120 because we are only buying 4 quantities of capital and 0 labor. Similar you can see cost of second combination is price of one capital is 30. 30 multiplied with 3 is equal to 90, and as we know firm buying 3 unit of labor and price of per unit of labor is 10. 10 multiplied with 3 is equal to 30. 90 plus 30 equal to 120. Similar you can see all combination, cost of all combination will equal to 120. So we can say that isocost line represent various combination of labor and capital which a firm can purchase at given price of labor and capital and with given amount of money. When we convert this table into diagram, we will get this. In this diagram on x-axis we have labor and y-axis we have capital, and these are combination A, B, C as we earlier discussed. When we join all this combination, we will get one line. This line will be called our isocost line. Now we are going to talk about least cost combination, or we can say the producer equilibrium. Producer equilibrium basically tells us how a producer can earn maximum profit within his cost limit. And there are 3 conditions of producer equilibrium. First is isoquant curve should be tangent to isocost line. Next is slope of isocost line should be equal to slope of isoquant curve. Last is at equilibrium level isoquant should be convex to origin. Now with the help of this diagram we will understand producer equilibrium point. In this diagram on x-axis we have labor and y-axis we have capital. AB is our isocost line. This AB is our isocost line. IQ1, IQ2 and IQ3 are isoquant curve. E is producer equilibrium point. At this equilibrium point, all condition of producer equilibrium are satisfied. At this E point, you can see isoquant curve is tangent to isocost line plus slope of isocost line is equal to slope of isoquant curve, and at this equilibrium point you can see isoquant curve is convex to origin. So at this E point all condition of producer equilibrium are satisfied. So we can say that this E point will be called producer equilibrium point. We cannot establish our equilibrium on this R and S point because R and S point are on lower isoquant, and lower isoquant give us less amount of output. We cannot establish our equilibrium on this higher isoquant. No doubt this higher isoquant will give us more output, but this is crossing our expenditure limit. Our expenditure limit is tell by this isocost line, but this isocost curve is crossing our expenditure limit. If we establish our equilibrium on this isoquant, our expenditure will increase. That's why we cannot establish our equilibrium at this higher isoquant curve. So this will be called producer equilibrium point. All condition of producer equilibrium are satisfied at this point. Now we are going to talk about Cobb-Douglas production function. This production function is based on empirical study of American manufacturing industry. This production function is based on empirical study of American manufacturing industry. And this study is done by Paul H. Douglas and C.W. Cobb. And this production function is not like other production function like law variable proportion or return to scale or isoquant. This production function is very different because this production function basically describes technical relationship between amount of input and amount of output. This production function only takes two input, labor and capital. And equation of this production function is Q equal to A L to the power alpha and K to the power beta. Or we can say the A L to the power alpha and K to the power 1 minus alpha. Here Q is output, L is labor, K is capital. Alpha means output elasticity for labor. That means how much output will change to change in labor. Beta is output elasticity for capital, means how much output will change to change in capital. A is all factor productivity, and all factor productivity depend on technology, and here we assume A is constant. Cobb-Douglas production function mainly based on linear homogeneous production function. Linear homogeneous production function means constant return to scale. So we can say the Cobb-Douglas production function mainly based on constant return to scale. As we know, constant return to scale means percentage increase in output is same as compared to percentage increase in input. For example, one labor and one capital are giving 100 unit of output. When we increase our labor and capital from 1 to 2, our output will increase from 100 to 200. Here you can see percentage increase in input is 100% and percentage increase in output is also 100%. So we can say that we are getting constant return to scale. And Cobb-Douglas production function mainly based on constant return to scale. But how we can know from this equation we are getting constant return to scale or not? If alpha plus beta is equal to 1, that means we are getting constant return to scale. Suppose the value of alpha is 3 over 4 and value of beta is 1 over 4. Now in this equation we will put value of alpha and beta, and when we add 3 over 4 and 1 over 4, this will become equal to 1. So we can say that here alpha plus beta is equal to 1. If alpha plus beta is equal to 1, that means we are getting constant return to scale. If alpha plus beta is more than 1, that means we are getting increasing return to scale. If alpha plus beta is less than 1, that means we are getting diminishing return to scale. So we can say that this production function mainly describes technical relationship between amount of input and amount of output. So this is all about theory of production. I think you got it, and thank you so much for watching this video. Bye, take care.